Measures of relative standing, all about z-scores and box plots. Okay, 5a, be able to explain what a z-score is and what the sign positive or negative means. Nice little solution here. A z-score measures how many standard deviations a single data point is from the mean. A positive z-score implies you're above the mean, while a negative z-score implies you're below the mean. And we'll do two examples of that in just a second. So, first of all, let's go ahead and read through 5b. My height is 72 inches. The mean height for the math professor is 67, while a standard deviation of 2 inches. Find my z-score. Is my height unusual for math teachers? So, a few things I want to point out about this problem. First, I tell you directly how to solve this problem. Find my z-score. I will not be doing that on the real exam. I'm being really nice to you. So just know that you need to know that whenever you see the idea of finding something unusual or not, one way to check for something unusual is to find a z-score. Okay? Now, going back to the problem itself, my height is 72. That tells me that my data point is equal to 72. The mean height for math professors is 67. That's going to be my mean of my sample, 67. Then I've got a standard deviation of 2 inches. Again, standard deviation of 2 inches. So I've identified what I've been given. I've also identified how I'm going to solve it. I'm going to be finding a z-score. Now I just need to remember that to calculate a z-score, I calculate z is equal to x minus x bar all over the standard deviation, or the data point minus the mean divided by the standard deviation. You can calculate using the other formula for parameters. Z is equal to x minus mu all over standard sigma. Same idea, just with population instead of sample. Continuing on with my sample example, I'm going to go ahead and take 72 minus 67 all over 2. I'm calculating my z-score. That's going to give me 5 over 2, or 2.5. So my z-score for my height is 2.5. What that means in this situation, my height is 2.5 standard deviations above the mean. And that's a good thing. And the reason I know it's above is because my z-score is positive. That's just not surprising because my sample of 72 inches is quite a bit taller than the mean of 67. Now, continuing on to the next example, it's the same similar idea. I want to know, is my weight unusual for math teachers? In this case, I know whenever I'm trying to find if something's unusual, I'm going to find a z-score. So, reminding myself, the z-score is calculated by the data point minus the mean all over the standard deviation. In this case, I've got a sample of 175. It tells me that the mean weight is 220. And I've got a standard deviation of 12. Substituting in what I know, 175 minus 220 all over 12. When I calculate that out, I should get a z-score of negative 3.75. Again, that shouldn't be too surprising because my weight, my sample, is quite a bit lower than the mean. Now, what this negative 3.75 means, that tells me that my weight is 3.75 standard deviations below, because it's a negative, below the mean. That's pretty cool. I can tell you that I am drastically undersized for a math teacher. Now, I made all those stats up, but it's still a pretty cool example. Last question on this page, asking you to compare and really figure out which one is more different than the norm. And by norm, I really mean the mean. So which one of these is more different than the mean? Well, you could look at the values and look at the mean. That's kind of hard to decipher by looking at the data. You can't determine just by the data which one's more different than the mean. But the good thing is that z-scores allow you to compare two different sets of data. A z-score of 2.5 tells you you're 2.5 standard deviations away from the mean. A z-score of negative 3.75 tells you you're 3.75 standard deviations away from the mean. So if you're trying to determine which one is further away from the mean, think of the mean and the z-scores like this. The mean is located right here in the middle of the data. And right below that mean is going to be a z-score of equal to 0. Now, if you go to the right of that z-score, you're going to have a value of the mean plus 1 standard deviation, something we've been talking about. And if you have the mean plus 1 standard deviation, then you're at a z-score of about 1, because you're 1 standard deviation away from the mean. Same thing occurs on the negative side of the mean. You could have the mean minus 1 standard deviation, or a z-score of negative 1. Continuing on, you can continue to do this with the positive 2 and negative 2. So mean plus another standard deviation. So that's 2 standard deviations. You've got a z-score of positive 2. And then the opposite side, you've got the mean minus 2 standard deviations, and you've got a z-score of negative 2. So mean minus standard deviation, and you've got a z-score of negative 2. In our example, we were given 2 z-scores. We were given a z-score of 2.5, which would go in the plot right about here, and that z-score had to do it associated with the height, because we know it's above the mean, and then our other z-score was associated with the weight, and it was about a negative 3.75. Now, it's so far over here to the left that it doesn't really even show up on my graph, but it would be roughly about here, negative 3.75, and that was actually associated with the weight. Sorry about that. So you've got the 2 different z-scores along that graph. A perfect value, one that would be equal to the mean, would be a z-score of 0, but we've got 2. We've got 1 equal to 2.5 z-score and 1 equal to negative 3.75 z-score. If you're considering which one of these is more abnormal, more different than the norm, you got to think about which one is further away from that mean. And in this case, the value of 2.5 is a distance of roughly 2.5. The value of negative 3.75 is a distance of roughly 3.75. So if you're looking at which one is more different than the norm or more abnormal, the weight, in this case, is more abnormal.